Okay, greetings one and all, and welcome to this math video. In this video, we'll be considering a Bgcse past examination. This is taken from 2011, and this is a mathematics Bgcse paper 1 past exam. Let's consider question number 1. Question number 1 says, convert 64% to a fraction in lowest terms. Very important to note that it's a fraction in lowest terms. So first, how do you write 64% as a fraction? Well, 64% as a fraction is 64 over 100. That's 64 over 100. And so, but we want this fraction to be represented in what? In lowest terms. And so we have defined a number that can go into both 64 and 100 without leaving a remainder. And so let's consider 4, because if we divide 64 by 4, we get 16. And if we divide 100 by 4, we get 25. And so here, this is definitely in lowest terms because there's no number besides 1 that can go into both 64, that could go into both 16 and 25 without leaving a remainder. And so this fraction is definitely in lowest terms. So the answer to this question is 16 over 25. Now let's look at question 1b. Here we have 7 and 3 over 8, and they say that they want us to convert this to a decimal number. Now before we convert it into a decimal number, let us take 7 and 3 over 8 and write it as an improper fraction. How are we going to do that? Well, we're simply going to multiply 7 by 8, and 7 times 8 is 56. And we're going to add that to 3. So we have 56 plus 3. What is 56 plus 3? Well, 56 plus 3 is 59. That becomes our numerator. And how about our denominator? Well, our denominator is the same as this one, so it's going to be 8. So 7 and 3 over 8 written as an improper fraction is 59 over 8. Now, what we're going to do here is we're going to take 59 and divide it by 8 because the fraction bar means division. And so when we divide 59 by 8, we get when we divide 59 by 8, we get 7.375. And so the answer to this question is 7.375. So 7 and 3 over 8 written as a decimal number is 7.375. Okay, let's move on to question number 1c. It says 0.036. We have to convert that to a percentage. Again, we want to convert 0.036 to percentage. How will we do that? Well, all we need to do is multiply by 100. So 0.036 multiplied by 100 is 3.6. And so 0.036 written as a percentage is 3.6%. Okay, now let's consider question number 2. Question number 2 says, calculate the value of 9 squared minus the cube root of 64. You may be familiar with the square root, but this is the cube root of 64. So the question is, how are we going to do it? Well, let's first consider 9 squared, or 9 to the power of 2. What does that mean? Well, 9 to the power of 2 simply means 9 times 9. And we know that 9 times 9 is 81. 9 times 9 is 81. But what about this cube root of 64? What does that mean? What's that all about? Well, the cube root of 64 is definitely 4. Why is that? Because 4 times 4 times 4 is 64. And so that's why the cube root of 64 is 4. Okay? So now that we know what is 9 squared, we know that's 81, and we know that the cube root of 64 is 4, let us combine all that information to figure out the value of this numerical expression. And so we have 9 squared minus the cube root of 64. We know that 9 squared is 81. And we know that the cube root of 64 is definitely 4. And so we subtract because we have the subtraction symbol. So 81 minus 4 is definitely 77. So the question, so that means that the correct answer to this question is 77. Moving right along, we have question number 3. Notice carefully this question. It says, one plant is now 12 centimeters tall and will grow 2 centimeters per week. A second plant is now 3 centimeters tall and will grow 5 centimeters per week. Calculate the number of weeks it will take for both plants to be at the same height. So let's consider this table. We have this first plant. It is 12 centimeters, and every week it increases its height by 2. So every week we have to add 2 to its previous height. And so after the first week, well, By the way, this for the second plant. Let's consider that as well. The second plant, it is 3 centimeters, but every week it grows 5 centimeters. Okay. So let's consider this first plant. Let's consider how it will grow. Okay, so 12 centimeters after 1 week, it grows by 2. So it's going to be 14 centimeters. And after the second week, it's going to be 16 centimeters because we just add in 2 each time. So 12 plus 2 is 14. 14 plus 2 is 16. And then on the third week, it would actually be 18 centimeters in height. Let's consider the second plant. Well, after the first week, it will be 8 centimeters. After the second week, it will be 13 centimeters. Again, we're just adding 5. And then after the third week, it will be 18 centimeters. And so that means that the number of weeks it would take for both plants to be the same height is definitely going to be 3 weeks, because after 3 weeks, we find that both plants are 18 centimeters in height. Okay, let's consider question number 4. Question number 4 says, complete the diagram so that it is symmetrical about both the x and the y axes. And so what happens here is we have the y-axis, which is the vertical one, and we have the x-axis, which is the horizontal one, and we have this figure that we have to make it symmetrical about both the y and the x-axis. And so what we're going to do is we're going to consider this diagram. We're going to look at y as the line of symmetry. And so if we look at this, notice that this is a 1, 2 units away, and this is going to be what, 1, 2 units away. And notice that this is what, 1, 2 units away, and this is also going to be what, 1, 2 units away. And so that is this one on this side. But let's consider when our x-axis is that line of symmetry, how are we going to do it? And so if we look here, we have this image, and let's make it symmetrical about the x-axis. And so we have this figure here. Notice that we have 1, and then we have what, 1, 2. And so that's going to be what, 1, 2. And even if you look at this one, this is 1, and so it's going to be what, 1 as well. And so to complete the image, we'll just do this. And so now this image is symmetrical about both the x and the y axis. And so that's how we complete that particular diagram. All right, let's move on to question number 5. Question number 5 says that we need to simplify this numerical expression. Notice here that we need to use order of operations. And order of operation tells us that we have to do it in the parentheses first. And so we have to do 9 minus 4. Well, what is 9 minus 4? Well, 9 minus 4 is definitely 5. And so we bring down the 5, we bring down the plus sign, we bring down the times, and we bring down the 2. But we have 4 times 5. How do we know it's multiplication? Because once they're adjacent, once they're side by side, just like that, that implies that we have to multiply them. So it's 4 times 5, and 4 times 5 is definitely 20. But why do we multiply before we add? Well, we multiply before we add because that's how the rule goes. Multiplication always goes before addition. So you have to multiply before you add. So 4 times 5 is 20. Again, we have to multiply before we add. And 20 multiplied by 2 is 40. And 40 plus 5 is 45. And so the correct answer to this question is 45. Moving right along, we have question number 6. It says a certain brand of peanut butter comes in jars of 2 sizes. The larger jar is 32 ounces and sells for $2.99, while the smaller jar is 18 ounces and sells for $1.59. Calculate and state which is the better buy. Show working to support your answer. And so when we're considering these 2 jars, we have to notice that when we say better buy, what we mean is which one is the cheapest. All right. So that's what we basically mean in this context. Which one costs less? And so the 32 ounces, you get 32 ounces for $2.99. That's for the larger jar. And for the smaller jar, you get 18 ounces for $1.59. Which one is the better buy? So in order to figure out which one is the better buy, we're going to figure out, okay, at this price, how much I getting? How much I getting? How much does 1 ounce cost at this price? So if we do 32 ounces for $2.99, how much does 1 ounce actually is costing me? And so in order to figure out that answer, we have to divide. So we say $2.99 divided by 32. And so the answer is 0.0934375. So basically you pay in about 9 cents for 1 ounce at this price. Okay, let's look at the smaller jar. So we have 18 ounces at $1.59. And so what is the price of 1 ounce? Like how much is 1 ounce costing me at this rate? And so we have $1.59 we divide, and so it's going to be 0.0883333 and continuing. And so basically for 1 ounce, it costs you about 8 cents. So here for 1 ounce, it costs you about 8 cents. And then here at for the larger bar, and so at for this one, 1 ounce costs you about 9 cents. So what is that telling you? That's telling you that the smaller jar is cheaper. And so which one is the better buy? The better buy is definitely the smaller jar. That's question number 6. Moving right along, let's move on to question number 7. It says Linda's flight left Chicago at 8:50 a.m. and arrived in Nassau at 12:35 p.m. the same day. How long was the flight? So we're trying to figure out the duration of a flight. She left Chicago at 8:50 a.m. and she arrived in Nassau at 12:35 p.m. So we always put the ending time at the top. So we have 12:35, so 12 hours, 35 minutes. And the time that the departure time, the time that she left, we put at the bottom. It's 8:50, so it's going to be 8 hours and 50 minutes. We have to subtract it, so we put the subtraction sign, and so we say, okay, 5 minus 5 is 0, 3 minus 5, but we cannot do that, so we must borrow. It's very important that we are borrowing from the hour side. And so we're going to borrow a whole hour. So 12 minus 1 is going to be 11. We're borrowing a whole hour. Okay, so since we're borrowing a whole hour, 1 hour is 60 minutes. And so that means when we come to the minute side, we have to put 60, right? We're not going to put 1 here. We're going to put 60. Why? Because we just borrowed literally a whole hour from the hour side. And so let's move on. So that leads us to write on this side the question again. And so here we have 60 plus 35. If we add them, that's going to be 95 minutes. And we're dealing with 11 hours. So let's put that there. Again, we're still subtracting. And so it's still 8:50, but we're still subtracting. Now we can subtract, okay? Because we just borrowed. So 5 minus 0 is 5. And 9 minus 5 is 4. Okay, so this is actually supposed to be 5. Okay, so let's change that. This is actually supposed to be 5 because 5 minus 0 is 5. So let's make a correction to that. This is actually supposed to be 5. Okay, and 11 minus 8. What is 11 minus 8? 11 minus 8 is definitely 3. And so how long was our flight? Well, our flight was 3 hours. Okay, 3 hours and what? 45 minutes. Okay, please make that correction. It is not 0. 5 minus 0 is 5. So the answer, so this is actually supposed to be 5. So it's 3 hours and what? 45 minutes. That's how long our flight was. Okay. So let's move on to the next question. The next question, 7B. 7B says, it took another 1 hour and a half before she finally arrived home. At what time did she arrive home? But remember, if we look at it, notice question 7. She arrived in Nassau at 12:35 p.m. Okay, and so that's what time she arrived at Nassau, but that's not the time that she arrived home. So she have to travel to get home a certain distance, and so it took her an hour and a half to finally reach home. And so she arrived in Nassau at 12:35. That's what we're gonna start with, but we have to add an hour and a half. An hour and a half is basically 1 hour and 30 minutes. Okay, so hour and a half is 1 hour and 30 minutes, and so we're gonna add that. 5 plus 0 is definitely 5, and 3 plus 3 is 6. And then 2 plus 1 is 3, and then 1 plus 0 is 1. And so what time did she arrive home? Well, she arrived home at 13:65. But we don't read time like that, 13:65. What does that mean? Let's break it down. So we have 13 hours and 65 minutes. Let's break it down. We can take 65 and we could make 65, or we could break it apart into 60 and 5. And so 65 is just what? 60 plus 5. So we have 13 hours plus 60 plus 5. But what is 60 minutes, right? What is 60 minutes? Well, 60 minutes is actually an hour. And so let's write that down. So we have 13 hours plus 1 hour, because 60 minutes is an hour, plus 5 minutes. And so let's add it together. What is 13 plus 1? Well, 13 plus 1 is going to be 14. So it's actually 14 hours and 5 minutes. So 1365 is actually 14. So 13 hours and 65 minutes is exactly the same amount of time as 14 hours and 5 minutes. It's the same thing, okay? Just written in a different way. But what is 14? What is 14 hours and 5 minutes? Like, what is that in terms of our actual time? Well, 14:05 is actually 2:05. So in army time or in military time, 14 hours is 2 o'clock. So 14:05 is going to be 2:05 p.m. And so she arrived home at 2:05 p.m. So that's the time that she arrived home. And just to give you like a chart between military time and civilian time, we see that 14 hours, all right, is actually 2 o'clock p.m. So 14:05 is 2:05 p.m. Okay, so let's move on to question number 8. Question number 8 says, a beverage set consists of a mug, a coffee pot, and a serving table. The mug costs $P. The serving plate costs $5 more than the mug. The coffee pot costs 4 times as much as the mug. A, complete the table, complete the table, expressing your answers in terms of P. And so we know that the mug costs $P, and the serving plate costs 5 more than the mug. So if the mug costs $P, the serving plate costs $5 more than that. And so it's going to be P plus 5. How about the coffee pot? Well, the coffee pot costs 4 times as much as the mug. And so we're going to say 4 times P, because the mug costs $P. Okay? So let's move on to question 8b. It says, write the total cost of the set in simplest form in terms of P. Okay, so how much is the mug? The mug costs $P. That's how much the mug costs. Okay, how much is the serving plate? Well, the serving plate costs P plus 5. That's what we have here. That's the serving plate. Okay, how much is for the coffee pot? Well, the coffee pot costs 4P. That's 4 times P, but we can write it as 4P if you put them together. So 4 times P can be written as 4P. They mean the same thing. It means multiply. Okay, so let's add it together because they want it in simplest form. So this is actually 1P plus 1P, and 1P plus 1P is definitely 2P. So we have 2P plus 5 plus 4P. We only could add like terms. So we have 1P plus 1P, that's 2P, and then plus 4P. Altogether, that's going to be 6P. And 5 is not the same, it's not a like term with P, so we just leave it like that. So it's 6P plus 5, and that's our answer, literally 6P plus 5. How do we get that? We add 4P plus 1P, make it 5P, plus another P, make it 6P. And so we have 6P's, and then plus 5, because 5 is the loner. There's nothing we can add it to, because there's no other like term. So it's just 6P plus 5. Okay, moving right along, we have question number 9. It says, write down the value of 13.64 raised to the second power, 13.64 squared exactly. So if you go in your calculator and you evaluate this numerical term, it'll just be 186.0496. And so that is 13.64 squared written exactly. And that's the answer. Now let's move on to question B. They said, okay, take the same value, let's take the same number and write down the value to 1 decimal place. Okay, so we still have 186.0496, but we want it to 1 decimal place. And so we have to look at 4, right? Is 4 greater than 5 or less than 5? 4 is less than 5, so we cannot add, we cannot add 1. And so we just leave it as 1.86.0. But if 4 was greater, but if we had a number 5 or greater, then we could add 1 to it. But that's just not the case for this one. Let's move on to question number C, 9C. It says, write down the value of 13.64 squared to two significant figures. Well, the first two significant figures here is 1 and 8. And so let's make a cutoff point. Let's underline 6. 6 is very important. 6 is greater than 5, and so we could add 1 to the 8. And so it's going to be, we keep the 1. And remember, it's 8 plus 1, so it's going to be 9. And everything else, we just turn it to 0. And so, and we don't write the numbers behind the decimal point, so it's just 190. Okay, 190. So let's move on to question 9D. It says, write down the value of 13.64 squared to the nearest 100. To the nearest 100. And so 1 is in the hundreds place, so we have to look at the number behind 1, which is 8. And we see that 8 is definitely greater than 5. And so we could add 1 to this 1, which makes it 2. And so 186.0496 to the nearest 100 is actually 200. So we drop all of the numbers at the back. And we turn these other numbers here, the 8 and the 6, into zeros. That's how we round it. Now let's look at a sets question. So here it says the Venn diagram shows sets P and Q contained in the universal set. And so we have a big set P, and we have a smaller set that is within P. The smaller set is actually Q. And so the way how we say this is that we say that Q is a subset of P because Q is in P. You can imagine a baby and a mother. So Q is the baby, P is the parent. And so it says list the elements in the set. P, this U symbol means union. So P union Q. And all that means is that we want all the elements in set P and U combined. So what is inside P and U combined? Well, Y is there. So we could have to put Y. T is there. All right. A is there. And W is there. So those 4 elements are in the set P union Q. We can't include X and Y, X and Z because they are outside of P and Q. So they don't go inside of the union. All right, let's move on to question A. Double I, it says list the elements in the set P intersect. So you see this upside down U, that means intersect. So we have to list the value of P intersect Q. Okay, what is that, right? So first, let's list off the elements of P first. Let's get that out of the way. What are the elements of P? Well, Y is in P, T is in P, W is in P, and also A is in P. So those are the values, those are the elements, those are the members of P, Y, T, W, and A. Again, we cannot include X and we cannot include Z. Now, how about Q? What are the elements that are inside Q? Well, T, W, and A, those are the elements that are actually inside Q. How about Y? Y is not inside Q. Y is inside P, but Y is not inside Q. And so the elements that are inside P is Y, T, W, and A, and then elements that are inside Q alone is just T, W, and A. But we want the intersection. We want what they have in common. And so what do they have in common? What elements do they have in common? Well, both of these sets have T in it. Both of these sets have W, and both of these sets have A. And so the intersection of these two sets is T, W, and A. Moving right along, we have question 10A, triple I. And it says, list the elements in the set Q complement. That's Q complement. And Q complement basically means I want everything that's inside the universal set except Q. Like we cannot include any elements that are inside Q. So all the elements are inside the universal set except for the ones that are in Q. And so X, Y, and Z are the only ones that we are left with. And that is Q complement, Y, X, and Z. And so let's move on to the next question. It says, write down the value of N of P. What this basically means is the number of elements. The way how we read this is that we want the number of elements in P. So how much elements are actually in P? Well, Y is in P, so that's 1. this is in P, even though it's also in Q, but it's also in P as well. It's like the baby and the mother, right? And so T is also inside P. So that's 2. So we have 1, we have 2. This is also 3, and this is 4. So the number of elements that are inside P is definitely 4. Let's move on to the next question, which is this one. It says we want the number of elements that are in P complement intersect Q complement. That's what we want. So let's first of all, let's list off like what is P complement? Like what in the world is that? Well, P complement is everything that's inside the universal set except for the elements in P. So we don't want nothing from P. Like we don't want nothing from P. And the only ones that are left, if we take out P, is just gonna be X and Z, right? That's all what's left. And so P complement is just XZ, because remember, we want everything except for the elements in P. And so we can't include none of these elements, just X and Y. That's P complement. That's those elements that are not in P. All right, now Q complement. Well, Q complement is the same idea. Remember, what we want to do is we want to figure out all of the elements that are not in Q, right? But are inside the universal set. So we have 3 of them. That's going to be Y, X, and Z. But they want the intersection of these 2 sets. And so what elements do they have in common? Well, these 2 sets have X in common and Z in common. And so that means that P complement intersect Q complement is actually XZ. Like only those 2 elements are inside that set. So the number of elements that are in P complement intersect Q complement is actually 2. And so the correct answer is 2. Moving right along to question number 11. It says here, a carpet is placed in a rectangular room. Make sure you pay attention to that word rectangular, because that's going to help us with area and stuff like that. So a carpet is placed in a rectangular room so that there is a uniform border 3 feet wide around the carpet as shown. The width of the carpet is 8 feet. The length of the room is 16 feet. So we have this carpet, right? This is the carpet. From here to here, that's 8 feet, right? That's 8 feet. And we have this border, and we have this rectangular room. So it's a big room, and the carpet is basically at the center. And each part is 3 feet away. All right, so this is 3 feet away. This part is also 3 feet away, and this part is also 3 feet away. So the question is, we want to calculate the length of the carpet. Like, how long is this carpet? We know its width. We know it's 8 feet wide, but how long is it? Like, how long is this carpet? Well, what we could do is we can say, okay, we know that the whole length of the room, like the entire length of the room, is 16 feet. But the carpet is not as long as that. The carpet is not 16. The carpet is not that big. The carpet is missing this side, all right, this side. And the carpet is also missing this side as well. And so if we could subtract 3 feet and 3 feet from that long length, then we could get how long the carpet is. And so that's what we're going to do. 16 feet minus 3 feet plus 3 feet. And so that's going to be 16 minus 6 feet. And so the length of the carpet is actually 10 feet, which makes sense because if you look at it, if this is 10, so if the length of the carpet is 10, right? So if the length of the carpet is 10, and we add 3, that's 13, and then we add another 3, because this is also 3, and that becomes 16. So the length of the whole room is actually 16, which makes sense. Okay, let's move on to question B. Let's figure out the area of the carpet. Well, that's nice because we already know the length of the carpet. The length of the carpet is 10 feet, and so area is length times width. Length of the carpet is 10 feet. The width of the carpet is 8 feet. And so we just multiply the 2 and we just get 80 feet squared. So that's the area of the carpet. Next, we have the width of the room. Like, how wide is the room? So we want the width of the room. How are we going to figure that out? Okay, so in order to figure that out, what we have to do is we have to add. Okay, we have to add. Notice that the width of the room is going to be 8 feet, okay, plus 3 feet, plus 3 feet. Why is that? So this is the width of the room, right? This is the width of the room right here, okay? We already know that this portion right here, all right, that portion from here to here, we know that that's 3 feet, okay? So that is 3 feet. We already know that from here to here, we know that that's what? That's 8 feet, okay? And we also know from here to here, that's going to be another 3 feet. And so we have 3 feet plus 8 feet plus 3 feet. Add them all together, we get not 80 feet. 8 feet, that's an error here. 8 feet plus 3 feet plus 3 feet is actually going to be 14. And so this is not right. This is supposed to be 14. Okay, so it's going to be 14 feet. Okay, and so the width of the room is actually 14 feet. Okay, and it's not 80. 80 is not correct. It's actually 14. Because 8 plus 3 plus 3 is actually 14. So now we want to figure out the area of the room. So how are we going to figure out the area of the room? Well, the area of the room is length times width. And so we do 16 feet times 14 feet. Well, what is 16 times 14? Well, 16 times 14 is going to be 224 feet. And because it's area, we know it's going to be feet squared. And so the answer is 224 feet squared. That's the area of the room. So we already know the area of the carpet. We already know the area of the room. Sorry, we already know the area of the room. And we already solved the area of the carpet earlier. And so the question is, what is the area of the border? And for that, we just need to subtract. The area is going to be, again, we're going to subtract, not multiply. There's an error again here. It's supposed to be subtract. So we have 224 feet, okay? And we have to subtract that with what? 14, okay? 14 feet. No, we have to subtract that. Let's look back at the area of the carpet. The area of the carpet was 80 feet. Okay, so the area of the carpet was 80 feet. So remember, the area of the carpet was 80 feet, and the area of the whole room was 224 feet. And so what that means is that in order to get the area of the room, we have to subtract. So let's do that. So in order to get the area, not the area of the room, the area of the border, we have to subtract. And so it's going to be, let's write this down. So let me write this down properly. Erase all ink. So the right answer that's supposed to be on the screen it should be, let's write it. So it's going to be area. So this is wrong. So put an X through that. So area is actually going to be equal to the area of the border now. We have to subtract the area of the room, which is 224 feet. Okay. Minus the area of the area of the room minus the area of the carpet, yes. And we saw that the area of the carpet was 80 feet. Okay, 80 feet squared. And so it's going to be 224 minus 80. What is 224 minus 80? That's going to be 144. Okay, and so the answer is going to be 144 feet squared. And so that's the answer, 144 feet squared. Because again, we subtract the area of the room and the area of the carpet to get the area of the border. And what we meant by the area of the border, what is the border? This is the border, okay? That's the border. All of that is the border. So in order to get the area of that, what we need is we need to subtract the area of the room and the area of the carpet. The area of the room was 224 feet squared, and the area of the carpet was 80 feet squared. So to subtract them, we would get the area of the border, okay? So moving right along, again, 144 feet squared is the answer. Okay, so let's move on to the next question. So the next question says, given that C equals to 6 and D equals to 12, calculate the value of 3D minus C squared. So basically for this, wherever you see D, you're going to put 12, and wherever you see C, you're going to put 6. And so let's do that. Again, D, you put 12, so that's 3 times 12, and C, you put 6. And so what we have here is 3 times 12. What is 3 times 12? Well, 3 times 12 is 36. And then 6 squared, what is 6 squared? That's 6 times 6. That's also 36. And so what we have is subtraction of the exact same numbers, 36 minus 36. And the result is only going to be 0. So the correct answer here is definitely 0. Now here we have question, this one is 12b. And so here we have a linear equation. And so we want to solve this linear equation. We want to make sure that x is isolated, x is the subject, and everything else is on the other side. And so notice that we have this number out front and we have some terms in brackets. So let's multiply, let's distribute, and let's see what is 3 times 5. Okay, so we're gonna do 3 times 5. We're gonna do 3 times x. 3 times 5 is definitely 15, and 3 times x is going to be 3x. So 3 times 5 is 15, and 3 times x is 3x, still equal to 17. Let's send this 15 over. So when we send this 15 over the equal sign, okay, it was a positive 15. Now it's going to be what? A negative 15. So now we have 3x equals to 17 minus 15. And 17 minus 15 is 2. Now we have to get rid of this 3, and the opposite of multiplication is division. So you're going to divide both sides by 3. And these two 3's are going to cancel with each other. And so we are left with x is equal to 2 over 3. And so that's the correct answer. X is equal to 2 over 3. Notice that x is on one side and everything else is on the other side. That's what we wanted. Okay, so here we have a geometry construction problem. And so we have this figure. It says using a protractor, so you have to use that geometrical instrument, measure and write down the size of angle B. Okay, so we have the figure like how much degrees, like what's the size, what's the measure of angle B? And so let's do that. So we have to use what they asked us to use. And so for this one, let's get our protractor and let's use what they want us to use. And so if we look at this, what we have is okay, so let's use a protractor. Let's use a protractor to measure the angle B. And so this is a protractor. So let's take this protractor and see what is the measurement of angle B. Like how much is its measure? Okay, so let's look at it. We start at 0. Notice our protractor is at the vertex of the angle, and we're going to start here. We go 0, 10, 20, 30, 40, 50, 60, 70, 75, 76, 77, and 78. So notice carefully. Let's do it again. 0, 10, 20, 30, 40, 50, 60, 70, 70. This is 70. This is 75. This is 76. This is 77, and this is 78, because then we go 79 and 80. So this is 78. And so that means that the measure or the size of this angle is 78. So let's write that down. That's going to be, let's go back. This is going to be 78. And so this is 78 here. So the measure, okay, of this angle B is 78 degrees. They already have the degrees sign, so I don't need to put it again. So it's 78 degrees. Here they say measure and write down the length of BC in centimeters. And so you have to measure the length of BC. Okay, so let's go back. How much does BC, what's the measurement of BC? For BC, we have to use a ruler. And so let's look at that. We start at 0, then 1, 2, 3, 4, 5, 6, 7. This is 7.1, 7.2, 7.3, and then 7.4. So if you look at that, that's 7.4 because after that, 7.5. And so the measurement of BC is actually 7.4 centimeters. And so the answer here is going to be 7.4 centimeters for BC. And so the measure of angle B is 78. And the measure of, the measure of angle B is 78 degrees. And the measure of the line BC is going to be 7.4 centimeters. Now notice C says using a pencil, ruler, and pair of compasses only, construct a 60-degree angle at A. So we have to go to A and construct a 60-degrey angle. We cannot use a protractor in the construction process. We have to use a pencil, a ruler, and a compass. And so let's look at this. And we have to do it at B. And so what we have to do is we have to make sure the tip of our compass is at A. Let's lock this in, make sure keep it locked in. Do not move or adjust the compass. And let's draw an arc like so. So we draw an arc. Okay, so let's draw this arc. And let's go the other way. All right, excellent. Next, we keep the compass the same size. We do not change the size of our compass. We do not adjust its size. So next, we go to where the arc intersects with line AB. And so let's go here and we put our tip right there. And so we're gonna go to the side and we're gonna draw an arc. We're gonna draw an arc that cuts the first arc. And so let's do that. And so this is the arc right here that cuts the first arc. And they didn't tell us how long they want our line to be. And so we're just going to draw a line from A that goes through Now you're going to use a ruler. Since I'm on a computer, I could use this nice straight line, but you're going to use a ruler to get this straight line. They do not tell us how long to go, but we want to make sure that we go a good length, but we want to make sure the key priority is to make sure that we intersect, that this line goes in the middle of the intersection of those two arcs. So let's use our protractor to measure and see if it's 60 degrees. It must be 60 degrees. And so let's look at it. This is going to be what? 60 degrees. And so if you look at it, this is 0, 10, 20, 30, 40, 50, and 60. And so that means that we constructed an angle at A that is 60 degrees in measure. And so this is how our work's supposed to look after we are completed. And so let's take that here and let's put it on this slide as the answer. Okay, so moving right along, let's look at this next question, question number 14. And it says the graph above is used to convert between US gallons and liters. Use it to answer the following questions. It says convert 9 gallons to liters. And so basically what we want to do is we want to convert 9 gallons to liters. And so this graph is very helpful because it can help us. So on the x-axis, we have gallons, and then on the y-axis, we have liters. And so we want to see how much, if we have 9 gallons, how much liters is that? And so basically the idea is that you would go to 9, all right, and you would go directly up, all the way up, okay, all the way, okay, and you would figure out where this graph and 9 connects, and then you would go on this side, on this end, all the way like here, and then you would kind of give an approximation of what that looks like, all right, like what it is. So at 9, what is it? Well, we know that it's not 35. It has to be lower than 35, okay? So let's count. This is 30. This is 30. This is 30. So this is going to be 32. This is going to be 30. Sorry, this is 31, 32, 33. And let me erase that. So this is 31, 32, 33. And this one is what? 34. Okay. And so if we look carefully, this is going to be what? 34. Okay. Now, if we go directly over, right? If we look at it, it's the same line. If we go directly over, right? We can see that right here, okay, right here is where we have it. But that's 34, okay? And so it's not exactly 34, because if you look carefully, let me make sure it's clear for you. Let's kind of zoom in. If you look at it, it's not exactly on 34. It's like 34.2, okay? Like it's a little bit, if you look at this line, it doesn't exactly cut it. It doesn't exactly reach, it isn't exactly on 9 at 34 exactly. It's like 34.2, right? And so the answer is definitely 34.2. Now, if you want to verify, I mean, of course, you could look at the graph and kind of estimate. But if you want to verify and make sure like your answer is precise, that you know for sure, okay, yes, 34.2 is the answer. One way is that you can just make an equation, because this is a line, this is a linear graph. So you can make an equation and you can substitute 9 into that equation, that function, that linear function. And then whatever it gives you, you know, that's the answer exactly for the leader side. And so let's do that. In order to create this linear function, we definitely need 2 points on the on this line. So the first point I'm gonna take the point 0, 0 because I'm absolutely sure that that's on this line. And I'm gonna call the first 0 x1. I'm gonna call the second 0 y1. And then we're gonna take these two coordinates. This is 10. And if we go over, that's 38 because this is 35, 36, 37. This is 38. So the coordinates here is 10, 38. So this is 10, 38, and we can call 10 x2 and y2 38. And so this linear function, because we could represent functions graphically, like how they have it here, but you can look at the function algebraically and you can so what we basically trying to do is we're trying to find out what is using algebra, like what is the exact value, because from looking at it, it looks like 34.2, but we want to verify, like, is it exactly like 34.2 for real? And so we see that we're trying to find m, because if we find m, because all we need to find this function, the function of that is represented by this line here, and all we need to do is we just need our m, the slope, and we just need a y-intercept. And so what is m? Well, m is the slope, and the formula for the slope is y2 minus y1 all over x2 minus x1. We know that y2 is what, 38, and y1 is 0, so 38 minus 0 is 38. And we know that 10 is x2 and 0 is x1, so 10 minus 0 is 10. And if we divide that, we get 3.8. So m, or the slope of this same line, right, is going to be 3.8. All right. Now, what is the y-intercept? The y-intercept is the value of y when x is equal to 0. So when x is equal to 0, basically where the graph, at which point does the graph cut the y-axis? And this linear graph cuts the y-axis at 0, 0. So that means that the value of y when x is equal to 0 is going to be 0. So that means that the y-intercept is 0. So let's put that all together. So m is 3.8 and b is 0. So that means that the linear function that represents the same graph here is actually f of x is equal to 3.8x plus 0. Since it's plus 0, we're just going to have f of x is equal to 3.8x. And this is powerful. This is very powerful because this can tell us the precise value of each one of these x values. And we don't even have to look at the graph, right? So this is definitely going to be powerful because we literally have the function algebraically. And so we have f of x. Let's figure out what is it at 9. So it says convert 9 gallons. So we're going to figure out, like, what is f of 9? And once we find what is f of 9, then we could figure out, like, how much liters is 9 gallons. And so f of 9, we put 9 wherever we see x. And so it's going to be 3.8 times 9. This would mean multiplication. And so 3.8 times 9 is exactly 34.2. And so that means that approximation that we had where we say, hey, this looks like this is 34 and that looks like 34.2. That approximation is absolutely correct. And so we verify that. And so the answer here is 34.2. Do you need to do all of this? I would recommend that you do, to make sure, especially when you're not exactly sure what the line is pointing to. I would recommend that you verify to see exactly what the right answer is. I would recommend that. But as you can see from just looking at the graph, we get very close. Okay, this is definitely 34.2. A good approximation we can get just by looking at it without even doing all of this working. And that's why it is only for 1 point, because you should be able to look at the graph and get a good approximation of what you're doing. Okay, so let's move on to question number 14b. Here we have convert 15 liters to gallons. And so here, instead of them giving you you know, the amount of gallons, they give you the liters. And so let's do an approximation based on this graph. We know that they want what, 15 liters? So 15 liters is right here. And so that's this line right here, 15 liters. And so that's here, okay? And so we want to figure out like how much gallons is that, okay? And so 15 liters, if we go down, this is 15 liters right there. So if we go down, right there, it's not exactly straight line, but if we were to go down, it's not exactly on 4, because if you look at it carefully, let me move all the red so you can see it with just my highlighter. So it's all ink. And so if you look at it, here, this is where right here, if let's zoom in, you see that at this point, that's where we have 15, and that's where this linear graph meets 15, and also meets a value on the x as well, but it's not 4. It's it's close to 4. All right. It's about that's approximated to like 3.9-ish. But let's see if that's right. Let's see if that's if 3.9 is the right approximation. Okay, so let's look at it. So f of x is equal to 15. That's what this is saying. So the value of our graph is 15. That's what they're saying. Liters is 15. And we know that f of x is 3.8. So 3.8x equals to 15. Divide both sides by 3.8. And we cancel. So x is going to be equal to 15 divided by 3.8. And what is 15 divided by 3.8? 15 divided by 3.8 is 3.9473 and continuous. So if we were to just consider it to 1 decimal place, it is 3.9 gallons. And so just by looking at the graph, you can give a good approximation that is 3.9, but you could use this to verify that, hey, it is 3.9. Okay, now here we want to convert 16 gallons to liters. And this is where your function becomes very important, because we only have up to 10, so we can't even look at the graph. And so we have to say, okay, f of x is equal to 3.8 times x. That's this linear function, right? That's this linear function represented algebraically. And so we plug in 16 into our function. F of 16 is equal to 3.8 times 16. And so what that means, we have 3.8 times 16. That means it's gonna be 60.8. And so that means that 16 gallons converted to liters is gonna be 6.8 liters. All right, so this next question says, hey, what is the cost? What is the cost of 36? Sorry, this one says that it's given us a statement first. So it's saying the cost of 36 liters of gasoline is $49.68. So if you know that 36 liters of gasoline is $49.68, like what is the cost of 1 gallon of gasoline to the nearest cent? And so we have to figure what that is. And so we know the cost of 1 gallon, of 1 gallon, all right? 1 gallon of gasoline, it's gonna be, we have to divide. And so we have to take $49.68 and divide it by 36. And with that, we get 1.38. And so $1.38 is for 1 gallon of gasoline. Okay, so let's move on to question number 15. This is geometry. And so we have a triangle. This is an equilateral triangle, because how do we know that? Like all the sides are equal. This side is equal to this side to this side. And so that means for equilateral triangle, you know that all the angles and all the sides are going to be the same. We have a right angle here. And so how are we going to figure what angle A is? Well, angle A, if it's an equilateral triangle like we just saw, like we just verified, that means that if this is A, well, we know that this is also going to be A. All right, all of the angles are going to be the same. And this is also going to be A because it's an equilateral triangle. So all of the sides and angles are the same. And so if we want to figure out how much is angle A, well, we have to divide. It's going to be 180 divided by 3, because we know the sum of the interior angles in a triangle is 180 degrees. So all of this together should be 180 degrees, but they're equal. So we have to split 180 degrees equally. into three parts, three equal parts. And so it's going to be 60 apiece. So this is 60, this is 60, this is 60. So that means that angle A is going to be 60. This is 60, this is 60, this is 60. All of them are the same thing. They add up to 180 degrees at the end of the day. Okay, let's look at B. Okay, so very important to note that we already know that this is 60. Okay, we already know that this is 60. Because it's an equilateral triangle, all of it is gonna be, all of the angles are gonna be 60. So like how are we gonna figure what B is? Well, we know the angles at a point add up to 180 degrees. So if this is 60, it's just gonna be 180 degrees minus 60, and that's 120. So B is 120 degrees. All right, moving right along, we have angle C. So we want angle C. This is supposed to say angle C. Let's make that correction. It's not supposed to be angle B. It's supposed to be angle C. So like, what is the size or what is the measure of angle C? Like, how are we gonna figure out like what is this? What is the measure of that? Well, this is 90, and so that means that this side is also gonna be what, 90 degrees? Because 90 plus 90 is 180 degrees, and they're on a straight line, so it's supposed to be 90 plus 90 is gonna be 180. So if this is 90, this side also must be 90. And we already know that this little small one right here, we already know that that portion right there, we know that's 60 degrees. Okay, and so that means that we know that this is 60, and we know that C and 60 combined is supposed to give us 90. And so that means we're going to do subtract 90 minus 60, which is going to give us 30. So that means that C is 30, which makes sense because if C is 30, right, if this is 30, then that means that 30 plus 60 is 90. And we know this side must be 90. So the answer there is 30. Moving right along, we have angle X. So they're saying like, okay, like what is the size of angle X? We have two parallel lines. We have a transversal cutting. What is the size of angle X? Well, if you look at angle X is a co-interior angle with 80. And so we know the co-interior angles add up to 180 degrees. You can tell co-interior angles because they form like a C shape. Okay, so it's like the C shape here. You can see it. And so that means that we have to subtract it from 180 degrees because co-interior angles add up to 180 degrees. And so 180 degrees minus 80 is going to be 100. And so X is equal to 100. That's the value of X. Just to show you co-interior angles, you notice that they form the C. And like we said, co-interior angles, we can get them by drawing a C shape, but they add up to 180 degrees. And that's what we was trying to explain in the first question. Now, angle Y, how are we going to get angle Y? Well, the first one was a C shape. This one is actually a Z shape because if you look at it, this here actually forms like a Z shape, okay? And so that's actually in alternate interior angles. And alternate interior angles are equal. And so if this is 30 degrees, this is also 30 degrees. And so Y is equal to 30 degrees. This is the alternate interior angles. Like we said, we get them by drawing a Z shape. And they are the same size. And so as you can see, the Z, those two angles here, A and A, they are equal. And so the previous question is definitely right with Y being equal to 30. Now we want angle Z, angle Z. Okay, so Z is here. And these here, they are definitely vertically opposite to each other. And vertically opposite angles are equal. So that means that Z is equal to 80 degrees. And so the answer is 80 degrees right there. Okay. Why? Because Z is vertically opposite to 80. Okay, let's move on to question number 16. Here we have Jason. Jason purchased his car from a used car dealer for $12,000. But he paid a deposit. His deposit was $3,000 and obtained a loan from the bank for the balance. So the question is, calculate the amount borrowed from the bank. Remember, he only borrowed like the balance. Like he only borrowed the amount he had to pay after the deposit. And so it's going to be $12,000 minus 3,000. And so he only borrowed 9,000 from the bank. So he didn't borrow the whole 12,000. He already paid the deposit. So he just borrowed a balance, and that's $9,000. Now he agreed to repay the loan in 3 years. That's the time. And the rates, that's the interest rate at 9% simple interest. And so calculate the total amount repaid to the bank. So let's first deal with the interest, because you have to pay the interest back as well. So let's deal with the interest. We know that for the interest, we need the principal. The principal is the amount borrowed. We know that that's $9,000 that he borrowed. We also need the interest rate. The interest rate is 9%. And we also need the time. The time always given in years, which is 3. Okay. So even if they give you months, always convert it back to years, because we always do simple interest in years. The formula for simple interest is principal times rate over time. Sorry, principal times rate times time divided by 100. And so P is 9,000. That's going to be right there. R is 9. That's 9. And T is the time. So it's going to be 3. And so we have 9,000 times 9 times 3. And that's what? That's going to be 243,000 over 100. Next, we divide both sides by 100. And so we're left with 2,430. Please bear in mind that this is just the interest, that he's accumulated over the course of 3 years. This is not the total amount that he has to repay, because remember, he still have to pay back the principal, like the 9,000 that he borrowed. So you have to pay the 9,000 plus interest. So the total amount repaid is going to be 9,000 plus 2,430. And so that's going to be 11,430. And so that's the total amount that he has to pay to the bank. Next question, it says, this is mean, median, mode type stuff. It says the daily maximum temperatures are recorded for a period of 8 days. It's 86 degrees, 89, and 86, and 84, and 87, 86, and 87, and 89. Write down the modal temperature. What do we mean by mode? Well, the mode is the number or the data point that occurs the most frequently. And so which temperature occurs the most frequently? Let's do it. Let's check. So 86, we find that 86 occurs like what? 1, 2, 3 times. So 86 occurs 3 times. So that's good. 89, how much times does 89 appear? Well, 89 appear twice. Okay, so that's frequency 2 times. And 84 only appear 1 time. And 87 appears twice. And so 87 is 2. Which number occurs the most? It's definitely 86. That occurs 3 times. Okay, so that occurs the most. And so the modal temperature is 86. Okay, awesome. Let's move on to question B. It says calculate the median temperature. Now we know the median is basically the number in the middle after you arrange the numbers in ascending order. It's the number that's in the middle. Now sometimes you might have 2 numbers in the middle. In that case, we'll show you what to do here. But we have the range. First of all, we arrange our data point in ascending order: 84, 86, 86, 86, 87, 87, 89, 89. And then we do some matching. So 84 goes with 89, 86 goes with 89, 86 goes with 87, and 86 and 87 are the 2 last in the middle. We just have to find the average of those. So we have to add 86 plus 87, because it's 2 numbers in the middle. If it just was 1 number in the middle, then our median was going to be whatever that number is. But when you have 2 numbers in the middle, we have to add them and then divide it by 2. So it's 173 divided by 2, which is 86.5. That is the median temperature, 86.5 degrees. Now we need to find the mean temperature. So with the mean, that's basically the average. You have to add up all of the data points and divide it by the number of data points that you have. And so that's 86 plus 89, 86, 84, 87, 86, 87, and 89. We add them all up. We get 694, and we have to divide that 694 by 8. That's the number of temperatures that we had. And so it's going to be 86.75. That is the mean temperature, 86.75. Okay, moving right along to this algebra question. Let's look at it. So we have 3 open bracket, a half minus 2x. How are we going to do that? Well, the first thing you have to do is multiply 3 by a half. And all it is multiplying 3 by 1 and leaving the denominator. And so next thing we have to do is we have to multiply 3 by 2x. Well, 3 times a half is 3 over 2 minus 3 times 2, which is 6. 3 times 2x, which is 6x. So it's going to be 3 over 2 minus 6x. We divide. It's going to be 1.5 minus 6x. And so that's the correct answer, 1.5 minus 6x. Moving right along, we have B. We have 8y plus 3z minus 5y, sorry, minus 5z plus y. We collect like terms. So 8y and y, we collect that's what we do. And then 3z minus z, we have to collect them and bring them together. And so we have 8y plus y plus 3z minus 5z. And 8y plus y is 9y, because 8 plus 1y, that's basically what it is. And then 3z minus 5z, well, that's going to be negative 2z. And so the correct answer here is ny minus 2z. Moving right along, we have 7w squared times 4w to the third power. And so how are we going to do this? Well, the first thing we're going to do is we have to multiply. So let's multiply the numbers separately and then multiply the letters separately. So we have 7 times 4. Well, what is 7 times 4? We know that's 28. And then we do the letters. So it's going to be w to the second power times w to the third power. And we know when we are multiplying terms with the same base, we add the powers. So it's going to be 7 times 4, 28, and w2 plus raised to the 2 plus 3, which is going to be 5. So the answer is 28 w raised to the fifth power. That's the answer, 28w raised to the fifth power. Let's move on to question number, let's move on to D. Well, D is a division problem. Let's bring them together. Let's bring the numbers together and then bring the letters together. That's the trick. And so what are we going to do? 15 divided by 5. 15 divided by 5, we all know that's 3. And then t to the 9th power divided by t to the 3rd power, we have to subtract that. And so we end up with 3t to the power of 9 minus 3. And so 9 minus 3, we know that to be 6. And so our final answer is 3t raised to the 6th power. Next question, question number 21 is a conversion problem. It says, complete the following conversions. We have 7.465 meters, and that's equal to blank centimeters. Complete the conversion. So we remember we can try to convert from meters to centimeters, and an acronym to remember, you can say knock him down, minister, don't commit murder. And so again, we're moving from meters to centimeters, and so that's twice, so that's 1, 2. And so let's move it. So it's going to be 1, 2. And so the answer there is 746.5. Next, we have 2,575 milliliters is equal to how much liters? Okay, so let's look at this acronym. Knock him down. This time Larry, because we changed units. Knock him down, Larry, don't commit murder. And so let's move from milliliters to liters. It's going to be 1, 2, 3. And so we have to move 3 times. So it's going to be 1, 1, 2, 3, just like that. And so the decimal point is here. So it's going to be 2.575. Now let's move on to this next conversion problem. We have 0.395 grams is equal to how much milligrams? For this one, we have to, again, use the acronym knock him down, but this time Grammy, don't commit murder. And so what we have here is we are moving from grams to milligrams. And so we have 1, 2, 3. And so that's how much times we're going to move over the decimal point. 1, 2, 3. And so the answer here is going to be 395 mg. So 0.395 g or grams is equal to 395 mg. So let's move on to question 21b. It says table salt can be purchased in a box, quantity of 1.5 kilograms. A full salt shaker holds 35 grams of salt. Calculate the number of salt shakers. The number of such calculate the number of such salt shakers can be completely filled out from that can be completely filled from 1 box of salt. Okay, so we have a problem because this is in kilograms, okay, and this is in kilograms and this is in grams. So let's try to make the units sort of universal so we can get to work. And so 1 kilograms equal to blank grams, and so we have to just multiply by 1,000 and we get 1,500. So 1.5 kilograms is actually 1,500 grams. Again, 1.5 kilograms is equal to 1,500 grams. And so we have everything in grams now. So we have this big box. It can contain 1,500 grams. And so how much, if you only have 37 grams of salt, like how much of them do you actually need? And so we did the maths. We just divide 1,500 divided by 37. And the answer is 40.54054054. Okay, so what does that mean? Well, if we want to figure out the number of boxes of salt shakers that can be completely filled from one box, is actually 40. Okay, and so we don't worry about these rest of numbers because they are not a complete box full. A complete box full that can be used from our group is going to be 40. And so the number of salt shakers that can be completely filled is going to be 40. Okay, so that brings us to the end of this video. Hopefully you find it to be helpful, and I'll see you in the next video.